We're going to start Unit 2 by reviewing some essential skills. The first is the Pythagorean Theorem. Recall that the hypotenuse is the longest side in a right triangle. So in a right triangle, the longest side, or the hypotenuse, is always across the 90-degree angle. If C represents the hypotenuse, and A and B represent the other two sides of the right triangle, then you should recall that the quadratic formula states that C squared is equal to A squared plus B squared. So the square of the length of the hypotenuse is equal to the square of the length of side A plus the square of the length of side B. So let's practice calculating a few side lengths for right triangles using the Pythagorean theorem. So example 1a. In this case we have the two legs of the triangle, so we can call them A and B. And our unknown is the hypotenuse, side C. So using the Pythagorean theorem, we have C squared is equal to A squared plus B squared. C is our unknown, so we can leave it as C or we can change it to another variable. But we know that side A, based upon our diagram, is 5, and side B is equal to 12. Next, we're going to add these two squares up. We're going to take 5 squared, which is 25, and add it to 12 squared, which is 144. The sum of those two numbers is 169. And that is C squared. Recall, if we want to get C then, we're going to square root both sides of the equation. The square root of C squared is equal to C, and the square root of 169 is equal to 13. So therefore we can say that side C is equal to 13 centimeters. Next, let's take a look at example B. Setting up the same thing. Start with the longest side, which is C. We actually know this time. We also know side A, if we call that one side A, and this time side B is unknown. So in this case, since B is unknown, I'm going to switch the equation around and say that A squared plus B squared is equal to C squared. Since I want to solve for B, I can minus the A squared from both sides, and now I have an equation for B squared. B squared is equal to C squared minus A squared. So let's sub in our values. So we have B squared is equal to, when we know C is 20.0 squared, minus the A, which is 14.0 squared. So we know that 20 squared, that's going to be 400.0, minus 14 squared, which is 196. If we subtract those two numbers, we end up with 204.0. That is what B squared is equal to. So again, we need to take the square root of both sides. And if we take the square root of 204, we're going to end up with approximately 14.3 centimeters. Now remember, this is an approximate answer, so I'm going to put a dot over my equal sign to say that I'm rounding my answer. The next topic we want to take a look at is slope and the equation of a line. Recall that we have two forms for the equation of a line. We have the slope y-intercept form, which looks like y equals mx plus b, and we have standard form, which looks like ax plus by plus c equals 0. In this lesson, we're going to focus on the slope y-intercept form. So if I want the equation of a line, there's two things I need to look for. I need to look for the y-intercept, and I need to look for the slope. The y-intercept is usually straightforward. It's where it crosses the y-axis. And then I also need the slope. So to find the slope, all I need are 2 points. And if I draw a triangle, I can find the slope by determining the rise over the run. And recall that the rise is just the change in y, or what we call delta y. And the run is the change in x, which we call delta x. And that tells us that the slope which is equal to m, is the rise over the run, which equals delta y over delta x. So let's go through how to find the equation of a line in slope y-intercept form given just the points on the line. So there are two steps that are involved in finding the equation of a line. But first, let's give a quick sketch of this line. So we have the point -1 and 4, and we have the point 3 and 4, 3 and -4. If we're to draw that line, we see we have a line that slopes downwards, so we need to have a negative slope, and passes through the y-axis at some point. So the first step is to determine the slope. So step 1, we're going to start with the slope. And we know the slope is equal to the change in y over the change in x. So all you're going to do is take the two y values from your equation, 4 and -4, and we're going to subtract them. But always do them in the same order. So I'm going to do point A, and I'm going to minus the component from point B. So what I end up with is 4 minus -4. That's the change in the y values. That's the height from A to B, the vertical height. Okay? So that's this here. That's your delta y. Now we need the delta x. That's the change in the x's. So if we look at the two here that we have, starting with A, we have -1, and then with B, we have 3. So we have -1 minus 3. 4 minus -4 equals 8, and -1 minus 3 equals -4. If we divide those two numbers, we see we have a slope of -2. And since our diagram shows a negative slope, this confirms it when we solve it algebraically. Now comes the next part. We need the y-intercept. And without sketching, there's an algebraic way to determine the y-intercept. So that's step 2. The y-intercept. So we know the equation of a line has the form y equals mx plus b. However, we've already found the m value. We know that the slope is -2 from above. So we have y equals -2x plus b. We just need to solve for the b value. And we have 2 points we can use. We can either use the point -1 and 4 or the point 3 and -4. So again, we can use the point -1 and 4 or the point 3 and -4, since they are both on the line. So I'm going to take the point -1 and 4, and I'm going to sub that in for x and y. So what I end up with is 4 equals -2 times -1 plus b, which gives me 4 is equal to 2 plus b, and to isolate for b, I am going to subtract 2 from both sides. And that leaves me with 2 is equal to b. So now I have the equation of this line. I have the slope from above, and I have the y-intercept. So the equation of this line is y equals -2x plus 2. A slope of -2 and a y-intercept that passes through the y-axis at +2. Alright, let's try this one more time. This time without the diagram. So starting from the top, we have our 2 points. So we know if we want to find the slope, we're looking for m. And m is the change in y over the change in x, the rise over the run. And from above, the y values are 6 and 7. So I'm going to subtract d minus c, as long as I keep it in the same order. So I get 6 minus 7. And then similarly, I'm now going to take the d value of 2, the delta x, and minus -1. So for the delta x, we have 2 minus -1. And it doesn't matter as long as you're consistent. You could have did 7 minus 6 over -1 minus 2, and it's still at the end, you're going to get the same answer. So 6 minus 7 is -1. 2 minus -1 is 3. So there's the slope for this line. So now we know we have the equation y equals, we know m is -1 over 3 x, plus we still need the y-intercept. So now I got to pick a point to sub into this equation. So again, we can sub in -1 and 7, or we can sub in 2 and 6. I'm going to pick 2 and 6. So if I do that, I get 6 equals -1 over 3 times 2 plus b. Remember, 2 is 2 over 1. So now let's multiply our fractions. So we get 6 equals -2 over 3 plus b. I'm going to move the fraction to the other side. So I get 6 plus 2/3 equals b. Since we need to add 2/3 to both sides. Remember, this is 6 over 1. So the equivalent fraction would be 18 over 3 plus 2 over 3 equals b. And we get 20 over 3 for our y-intercept, or our b value. And therefore, using our slope from above, which we saw was 1/3, and using our y-intercept of 20 over 3, we have the equation y equals -1/3 x plus 20 over 3. Okay, last part. In this last question, we want to talk about perpendicular and parallel lines to help us answer the question. So example 3 says, determine the equation of a line that is perpendicular to this line and passes through the point -1, -2. So let's go over the definitions of parallel and perpendicular. So last year you would have learned that parallel lines are going to have the same slope, so that the slope of line 1 is going to equal the slope of line 2. For example, if m1 equals 2, then a line that's parallel would have the same slope, and therefore the slope must be 2. For perpendicular lines, we say they have slopes that are negative reciprocals of each other. So the slope of 1 is the negative and the reciprocal of the slope of line 2. So for example, if the slope of line 1 was 2, and remember that's 2 over 1, then the slope of line 2 would be the negative of the reciprocal of 2 over 1, which would be -1/2. If the slope of line 1 was -2/3, then we take the negative of a negative, so it's going to be positive, and then we take the reciprocal, so positive 3 over 2. So the reciprocal just means flip the fraction. So now let's go back to our question. The question says, determine the equation of the line that's perpendicular to this line here, 1/4 x plus 7. So we know for line 1 that the slope of this line is 1/4. So for this new line, we'll call it line 2. The slope of that line must be the negative reciprocal, since we're saying perpendicular, and that would be -4 over 1, or just -4. We are also told that this line passes through -1, -2. So same as before, we have the new line as y equals -4x plus b. We know it passes through -1, -2, so we're going to use -1, -2 as a point. We're going to sub that in for x and y, so y is -2, x is -1 plus b. So we get -2 equals +4 plus b, and if we minus 4 from both sides to get b on its own, then we end up with -6 is equal to b. So our y-intercept goes through 0, -6. So therefore the perpendicular line would be y equals, using the perpendicular slope of -4 and the y-intercept of -6. So there is a line that's perpendicular to the line given here and passes through this point. So we're just using all the information that's given. So again, there are questions from your textbook. Plus, there is a worksheet that helps with slope and the equation of a line. So the textbook questions relate to Pythagorean theorem, and the worksheet relates to the topics we just discussed now.